Let's go on to question 17. Now, close examination of question 17 reveals that you've got 6 equations and 6 unknowns. Now, that is quite frightening because at most we have 2 equations and 2 unknowns at school. But this problem looks very much like an earlier problem we did. I think it was problem number 14. So, because if you look at each of those equations, first equation has got a plus b plus c plus d plus e, and f is missing. The unknowns are a, b, c, d, e, f. And the second one is exactly the same thing, but e is missing. And the third one, d is missing, and so on and so forth. Right? So if we give a name to the entire sum, like what we will do now, we'll say let S equal to a plus b plus c plus d plus e plus f. Then the first one, f is missing, so that's s minus f. And that will give you a plus b plus c plus d plus e, and that is 20. Likewise, the next equation is s minus e, and the next one is s minus d, the next one is s minus c, the next one is s minus b, finally you have s minus a, and these numbers are 20, 19, all come down by 1, 20, 19, 18, 17, 16, 15. All right, and like before, what we can do is to solve, we add on both sides. We add on both sides, and no, what did we want? We want a times b times yeah, so we add on both sides. So you have 6 equations. Add on both sides. You have 6s minus, and here you'll see the sum of all the unknowns, a plus b plus c plus d plus e, and that's exactly s. So if you add on both sides, you have that. And if you add all these numbers, I think you get 39, 57, 74, 90, 105. So 5s is 105, s is 21. Okay, so s is 21. So all these are 21. So you have 21. So f is 21 minus 20. 21 minus what gives you 20. So if you work out a times b times c times d times e times f, you will see that, say, s minus f e d c b a. You'll see here you have it's 21. This is 21. So f is 21 minus 20. The next one is 21 minus 19, 21 minus 18, 21 minus 17, and so on. So A, B, C, D, E, F is just 1, 2, 3, 4, 5, 6. So this is nothing else but 6 factorial, which is 720. So that's the answer to this problem. It looks so difficult. 6 unknowns, 6 equations, but there we have it. We can use a nice simple technique to solve the problem. Okay, let's just see. Oh, okay. So it's the same thing. You still come to 720. Okay, we go on to question 18 now. Now, question 18. It says the following. The sum of 50 different numbers from 1, 2 up to 100. Okay, we don't know what the numbers are, but there are 50 numbers chosen from this set. The sum of all that is 2,900. Question is, what is the smallest number of even numbers that could be part of the sum? Now look, this is quite a difficult problem. I want you to listen very carefully to the logic behind this problem. So you want the smallest number of even numbers which could be part of the sum. So let E be the set. We'll make it the sum. No, no. I don't want that. Just hold on, please. Yeah. So E be the set of even numbers in the sum that we are looking for. Sorry about the writing as usual. All right, so you got E. See, you got 50 numbers chosen from this. Amongst those 50 numbers, you will have several even numbers, right? So if you add, we'll call it S of E, the sum of E, and then you got the sum of the odd numbers. Right, so if you take all the sum of the even numbers in the set, the sum of all the odd numbers in the set, then we have this number here, 2,900. Because then we're adding all the possible numbers in that 50 numbers. E consists of all the even numbers in that 50, and S is all the odd numbers, the remaining part. Right. Now, you want to know the smallest number of even numbers. So you got the number of even numbers. Let n of E be equal to the number of even numbers. Okay, so, and likewise, the number of odd numbers. And we know that the number of even numbers plus the number of odd numbers is equal to 2,900. No, 50. 50, because there are 50 numbers chosen altogether. So just bear that in mind. And you want the smallest number of even numbers. So you want NE to be as small as possible. To be as small as possible. Okay, now remember in the first 100 numbers, there are 50 even numbers altogether, 2, 4, 6, 8 up to 100. and 1357 up to 99 odd numbers. So the 50 even numbers and 50 odd numbers. So you can start off by saying NE equal to naught. That's the smallest you can get. Means that N odd is 50, right? Which means that you're adding all the numbers, right? So the S of odd is the whole lot. It's 1 plus 3, sum of all the way up to 99. And you can, this is some of the first odd numbers. There is a formula for this, but you can work it out anyhow you want. And you will see that it's 2,500. So we've got the sum is 2,900. We are 400 short. Right? Which means that you have to make NE a little bit more. Right? 400 short. To make SE, the sum, or NE as small as possible, and you need to get the sum of those to be almost 400. You want very few even numbers. They're going to add up to 400. Let's take the largest even numbers, namely 100 plus 98 plus 96 plus 94. Now that is still short of 400 because each one of them is less than 400. And this is, if you work it out, because it's 388. Right. Okay, so we can't have four because if you so yeah, so you can replace the smallest odd numbers replace the first four 1 3 5 7 with in that way you can preserve the 50 numbers, you see, with 100 98 96 and 94. And then what do you have? You have that your sum. Then this new set of even numbers. So this will be equal to E now. Let E be equal to that. Then you'll have that SE plus S. Now, the other numbers will be from 9 onwards. That will give you 2,888. And you're still 12 short. Okay. What you can do is, yeah, the thing is now, the question is, you need to replace more odd numbers. But I can't replace one odd number to get 12. I'm 12 short. I have to replace it by at least 2 odd numbers. Right? So, actually, this is wrong here. Okay, we will come back to that. We know that we are short of this, and we are adding 16, you see. Subtracting 16 and adding these. So yeah, so we can't just replace by one odd number. We can't replace just one odd number because you got to you have to come up to 12. Um, Actually, it's not 12. Let's just work this thing out again. Um, you've got this 1357, 9 plus 11, all the way up plus 99. And then you add these 388, right? And this is actually 2000. This is 2500 minus the sum of these minus 16, right? And plus 388. Well, yeah, plus 388. So you got 2500 plus 372. Okay? Plus 372. And you're still at 2872, 28 short. So what do you have to do? You have to replace not one odd number, you have to replace two odd numbers. I told you have to be very on the ball listening here. So we are 28 short, right? And then we have to replace two odd numbers. The only two odd numbers, the next two odd numbers are 9 and 11. So replace 1357 and 9 and 11. Right? That's another 20. Yeah, you want that to add up to 28. Okay, so if you take out 9 and 11, that wouldn't work. So you need to have, say 11 and 17, right? Replace that, those six numbers with those numbers that we had, which is 100, 98, 96, 94. And then you are 28 short, 28 plus 20. Oh, no, it's 9 and 11. It is 9 and 11. So you have to replace six numbers. It was 4 and 2 with two even numbers, which add up to that. Okay, which add up to that shortfall. So I think you get like 22 and 26 or something like that. Now, I'm going to stop there for the moment and just have a look at what I've written. As I said, this is quite a tricky problem. So just bear with me. But I'm going to show you. You see, read this thing and you'll see that we actually needed 256. And these are the numbers. You replace 1, 3, 5, 7, 9, 11. So that is why you've got here, I will show you. Okay, if you look, so these will be the numbers that the 50 numbers that you will choose, going from 13 to 99. So you replace 1 up to 11, 1, 3, 5, 7, 9, 11. Okay, which actually adds up to 36, right? So this sum here is 2000 minus 500, 2500 minus 36, right? And then if you add those numbers which we had before, 99, I'll have to include 100 here as well. Sorry, it's 100 and those four numbers. And that will give you 2,900. This 400 minus 20 is from this thing here. I don't know why I didn't include 100. I could have included 100, but I started with 98 in this problem because it says I can include 100. Anyway, I chose those. It didn't make any difference. So that is why I got a slightly different sum here. So here it's 20. So the 400 minus 20 is the sum. Should have been 400, but this, you are short of 400 by 2 plus 4 plus 6 plus 8, right? So so you needed another 56 extra to get up to 2,900. Right, you can see how it works. And that 56 can come from 26 and 30. See, 26 and 30. And that will give you 6 numbers. So the smallest number of even numbers that you have is 6.